Assalamualaikum warahmatullahi wabarakatuh. Now we'll discuss about a couple, and of course after this we will continue to resultant, and the resultant will be specific to resultant of system of force. But before you watch this video, I recommend you to watching my previous video about the moment, because it will be correlated and make you easier to understand about this. What is the couple? The couple is the moment that produced by two equal opposite and non-collinear forces. It will be called a couple. So if you have two forces here, force 1 and force 2 equal, it's opposite, the direction is opposite, and non-collinear because it cannot be intersected at any point. If we combine this, it always be zero. In every direction, it's always be zero. So how we can calculate the moment of the point O? If you want to calculate the moment of the point O, we can use this equation where the moment will be obtained by F times A plus D minus FA, where if we operate this one, we will have FA plus FD minus FA, and we can remove this and it will be FD, the M is F times D. And what about the cross product? We also can use the cross product here. Using the cross product, we will have, if we have two, like the previous, we have two forces equal and collinear and opposite. We can use that by using the algebraic method. We can write that it is the distance from the point 0 to the point A. It calls the RA, and RB is the distance from the point O to the point B. So the moment of the O here is the RA times F plus RB times minus F, and it same if we write this one is the RA minus RB cross F. And you see that the RA and minus RB, it will be same like here it is, R is the RA minus RB. So this equation, it will come back to the R cross F. And it is the example of the equivalent couples that we can change the value of F and distance. It doesn't change any given couple as long as the product FD remains the same. It is this example. We have the four different form, but it will give the FD the same. Even you change the F and the D like this one, it still give the product FD the same, remain the same. It will be the same with this one, and also with this one. And for the force couple system is very important in the mechanical application. Maybe sometimes we are difficult to find the force at any point. By using the force couple system, we can replace the given force by an equal parallel force at a couple to compensate for the change in the moment of the force. And for example, if you have the force at a point A, we can move or replace the given force here to the point B. Please give the condition that in the point A we have the perpendicular, this one is to find the D, and is the opposite collinear, non-collinear, I mean the opposite and the equal. So we'll change this one, translate to the point B. So by using this one, we will get the value of M by using the point B. So we can replace from the point A to the point B, but it will be the same, will give the similar result. And what about the resultant? We are discussing about the resultant of the system of force here. That is the simplest force combination which can replace the original forces without altering the external effect to rigid body to which the forces are applied. So it is the resultant. We can combine of many more than two forces to be the one forces, and it can be applied to a rigid body without altering the external effect, of course, and then it will be the resultant of the force. For example, like this one, if you have the F1 and also we have the R1 here, where the R1 is come from the F2, the combination of the F2 and F3. So the combination of the F3 will be the resultant of R1 here, the resultant of the F2 and F3, and the combination of F1 and F2, which is the R1, we can combine with the F1. So in this condition we have 3 forces, so we can use 2 first and plus with the last one, which will be the resultant. Here is the resultant of 3 force, is the resultant of 2 force. So the resultant here, it will be the F1 plus F2 plus F3 and so on. Yeah, it will be the sigma F. And whatever the force that working in the x direction, we also can write the Rx, it will be the sigma Fx, and the Ry is the sigma Fy. And the resultant of that one, we can use the Pythagorean theorem that sigma f squared plus sigma fy squared. And how to find the angle of this? We still can use the theta. By using the theta, we can use the tangent for the power of -1 ry divided by rx, or tangent to the power of -1 sigma fy divided by the sigma fx. And one of the easiest method to find the result, and we can use the polygon method, where we can combine the head to tail. We are combining the head of the f1 to the tail of f2, and the head of f2 to the tail of f3. So we'll get the resultant of 3 force directly by using this polygon method. And if you want to solve this by using the algebraic method, we have the several steps. The first step, it is like the previous figure, that we have 3 forces here. By using the algebraic method, it will be different, totally different, because in the algebraic method we can directly move all of the f1 into a point of O. So in the O point, we will intersect all of the forces here, which is the F1, F2 and F3, and we will get the resultant of the sigma, or the sigma F of the 3 forces. And what about if you want to know the distance from the point 0, but this resultant? So we can use this equation that the distance for that, it come from the moment at the point O divided by the resultant. So if you have the moment here in the point O, it will be divided by the resultant. We will get the distance of the point O to the resultant of force. Okay, now we will start for the example. In the first example, we have the range. The range is subject to the 200 Newton force, and the force path shown if the equivalent of the two forces is a force R at O at a couple expressed as the vector M is 20 Newton meters. Determine the vector expression for P and R. So we have to determine the vector expression of the P here and the resultant of the force. So what the first step of this? The first step of this, we have to find the value of P. And the value of P we will find by using the Okay, now we have the value of P, where by using the moment is the sigma F times distance. Why we use the sigma? Because we have two forces here, the first forces and the second forces here. And remember that we have the value of moment given. We have 20. The first forces is 200 and the distance is 0,16 here. Please remember that I convert it to the SI unit from the 150 f 160 to be 0,16 meters, and then minus p times 0,3. So it means that signs of plus here, it revert to the counterclockwise, right? We have the value of p is 40 Newton meters, and the second one we have to find what about the r. So the r, it will be here is the r, it will be negative 160 g, where the g is the unit vector of this one. Because we don't know the unit vector of this one, we can write this by the notation of g. So we have the 200 times g plus 40g, and the resultant of this one is negative 160g. Now we are in the second exercise. We have a force of F of magnitude is 60 Newton is exerted on the automobile parking brake lever at the position X through 150 millimeters. Replace the force by an equivalent force couple system at the pivot point O. So remember that we just finished this principle, so we can use the force couple system at O. So what we have to find first, of course, we have to find the moment at O first. By using the moment, we find the moment at the point O. The value of this is 17,291 Newton meters. By using the calculation of F times D, we have the force, only one force here, but we have to project it in the X and Y direction because it's not in a normal direction. We have the angle here, but at 20 degree. So we have to project this force to be the vector component of the X and Y. And we have the 60 cosine 20 degree. It will be here, projected to the Y, cosine 20 degree, and 0.1 here revert to the SI unit of this. It will be the 0,1 meters, and the cos 25. Where the cos 25? The cos 25 is coming from this one. It's 15 plus 10 degree. It will be 25 because making the angle, because the angle is different here. Actually is plus 0,25, and 0,25 cos is the distance from the given information. 25 will be the 0,25 because it's conversion to the meters. Cos 10 here, the cos 10. So we'll have the F in the normal Y, and we have the distance from the Fy to the point of 0. And also we can use this one for the 40 sine 20 degree at the same logic, and we will have the moment at 17,291 Newton meters. That is the moment O. The equation is to replace the force by an equivalent force couple system at the pivot point O. So by using the force couple system, we have the R is the 50 Newton, and the M it will be 17,291 1 Newton meters. Please remember from the previous video that in the previous explanation about the first couple system, where we can replace any by using the condition of the moment. And then the third one, in the third exercise, we have to integral pulleys are subjected to the belt tension, just like this shown here. If the resultant R of this forces pass through the center O, determine the T and the magnitude of R and the counterclockwise angle, maybe it's theta here, it makes with the x-axis. So we have to obtain the resultant, the magnitude of T, and also the angle, whether it's a counterclockwise. So the first thing you have to find here is the moment at a point O, because by using the moment at a point O, we will get the T. Okay, by using the moment at a point O, we will use the FD again, okay, for the many times. We have used the 200, you have the force 200 here, and the distance here is 0, because it is the R2, I mean here is the R1 and is the R2. The distance here to this one is the R2, is 0,2 meters, and it will be the 0,1 meters times R2, and is a minus 150, also times R2, and 150 times R1, and T times R1. We will have the value of T, that it will be the 60 Newton. And then what's next? And then we have to find of the each component of Rx and Ry, because we need the resultant of all of these forces. So we have to find the Rx and Ry, and then we will find the R. Okay, now we have the Rx value here. We have the Rx value here, that 200, we are projected all of the force in the x direction. We have 200 here is in the normal force in the x direction, so directly it will be 200 for the positive, 150 for the positive, and then negative, because here we have the fine angle here. So projection of this force to here, it will be the Fx will be 160 cos 30 degree, and also is a minus 60 for the tension here, for the T here, T cos 30 degree, and we will find this as a 159,474 Newton. Next, we continue to find the Ry. To find the Ry is more simple, because we only have two forces here. Is here force this one and this one. It is the x direction, is x direction. It can project it to the y direction. So for the y direction, it's only two forces, 160 and 60 sines 30, and we will find that it is 110 Newton. And then what is the resultant? And then for this resultant, we can use the Pythagorean theorem, that the square root of this one is the Rx square plus Ry square, and it will be 193,731 Newton. And what about the angle? the angle, which is referred to the theta here. Theta I can use so the theta of the resultant, here will be tangent to the point of minus to the power of -1 ry divided by the rx, and where the ry divided by the rx will be the 0,69, and the theta angle, it will be 34,6 degree. And after you will give you the exercise, you have to try to solve this exercise. And thank you for watching this video. Assalamualaikum warahmatullahi wabarakatuh.